When you have a lot of data in your application, it's often important to visualize that data and analyze it in different ways so that users can get a better understanding of the data. And that's where we're going to introduce a Python library, and it's called PyGWalker. Now, when I first saw this library, I thought you would pronounce that PyGWalker, but apparently this is actually called PyGWalker. And what it is an open source alternative to an application like Tableau, which is used to analyze and visualize data. So PyGWalker is an alternative to that, and in this video we're going to take a data set and we're going to analyze and visualize that data with PyGWalker, and we're also going to see how to integrate PyGWalker into a Streamlit application. So let's get started. I have the documentation for PyGWalker open, and as you can see, it allows you to turn your pandas data frame into a Tableau style user interface for visual analysis. And this is extremely easy to do, so we're just going to dive into it in this video. And let's start by going to a Jupyter notebook. What we have at the top here is a pip install command that you can execute in the notebook in order to install the PyGWalker library into the notebook environment. So make sure you install that. What I'm going to do below that cell is import the pandas library as PD. And I'm going to load a bit of data into a data frame here by calling the 𝗦𝗡csv function, and we're going to pass a file name to that function. Now if we go to the desktop here and we go to the directory in which this Jupyter notebook is in, you can see we have a file here called 𝗦𝗫𝗃𝗫.csv. I'm going to copy the name of that file and paste it into the 𝗦𝗡csv function, and then we can output the head of this data frame. And I'm going to show you where you can get this data set in a second, but as you can see, we're getting a Unicode decode error. Now we're going to fix this error, but first of all, let's have a look at the source of this data set. It's data on US household income statistics, and this is from Kaggle. I'll leave a link to this below the video. You can download this data at the top right here, and once that's downloaded, you will have a file called 𝗏𝗏income.csv. So this is the data set. What we're going to do is go back to the 𝗏𝗡csv function, and it turns out we need to pass an encoding to this function in order to correctly read in the data to a data frame. And the 𝗏𝗡csv function in pandas can take an encoding keyword argument, and we can set that equal to, in this case, Latin 1. That's the encoding that we want to use in order to read in the data to the data frame. So when we execute this, when we get the head of the data frame back, we are now getting these rows in the data frame. So the data frame is now loaded from that file. And if we look at the data frame on household income statistics, you can see that we have, for example, states in the USA as well as counties and cities. And on the right hand side, we have some numerical data. For example, we have the mean and median incomes for that particular location, as well as the standard deviation of incomes over that region as well. And we also have latitudes and longitudes and some other numerical data as well. What we're going to do is use PyGWalker in this video, and we're going to create some visualizations on this data, and we're going to see how easy this is to achieve with a tool like PyGWalker. So let's scroll down to a new cell. And what I'm going to do in this cell is import PyGWalker, and we can do that as, in this case, PYG. So we're importing PyGWalker as pig. And then when we have the pig imported, what we can do is we can call pig.walk. And this walk function takes as an argument the data frame, and that can be a pandas data frame or a polars data frame. And when we call that pig.walk function, it will give us back an object that we can store in a variable called walker. So let's now execute this cell, and we're going to see what comes up on the Jupyter notebook for this particular function, pig.walk. So when we scroll down, you can see we have this visualization tool that has become available for us on the notebook. What we have is the ability to drop some of the columns that you see on the left hand side, which are coming from the pandas data frame. We can drop them onto the X and the Y axis of a chart in order to build up some charts using this tool called PyGWalker. So let's say that we wanted to look at the average or the mean income for each state in the USA. We can take the name of the states and we can add that to the x-axis of a chart. And what that's going to do is add every single state in the USA to the x-axis of a chart. And on the y-axis, on this bar chart that we're going to develop, we want to put the mean income. So if we scroll down here, you can see there is a column called mean. Let's use that mean column and drag it up to our y-axis and place it into the y-axis of this chart. And you can see we get back this bar chart here, and for each state in the USA it's showing the mean values, and these mean values have been summed up. We're performing an aggregation. So for example, there might be many entries in this data frame for the state of Florida. What this is doing is it's taking all of the means for each entry and it's summing them up. To get the true mean over Florida, we can set this equal to the mean. That's the aggregation column. And this gives us back a bar chart with all of the states in the USA and the mean incomes for those states. Now you might want to view this from the highest to the lowest or vice versa. We can actually sort the chart by simply clicking these buttons. So we can sort in ascending order, and we are going to get back the state with the lowest mean income first, and in this case that's Puerto Rico, followed by Mississippi here. We can also flip this round by clicking the descending order, and we can see that the District of Columbia apparently has the highest mean income, followed by Connecticut. So you can see how easy it is to build these charts with PyGWalker. We can also add filters to the charts to customize what is shown on the charts. For example, if we drag the state name into the filters column, we then get this modal popping up, and we can select a bunch of states here, and it's going to only add the states that we select to the resulting chart. So what I'm going to do is unselect every single state, and then I'm going to only select some of the states in the south of the USA. For example, Minnesota, and we also have North Carolina, Tennessee, let's select that one, as well as South Carolina. And I'm also going to select Florida. And if we scroll down a bit further, we can see also Texas here. So let's select those, and we can then confirm that selection. And you can see the resulting bar chart now only contains the states that we selected. So we've applied a filter to this bar chart in order to customize what's shown on the chart. Now you might also want to add a legend here or different colors for each state. We can also do that by dragging the state name into the color filter here, or the color field. And what that's going to do is apply a different color to each state in the data that's visualized in this bar chart. And when we do that, every bar in the chart has a different color, and there's also a legend telling us which color and which label belongs to each bar. And we can also change the layout of this chart. For example, we have a tool here called the layout mode, and that is set to auto, but we can change that to fixed, and then we can drag and drop this chart across the PyGWalker UI, and you can see that customizes the length and the width of the chart, and also the width of the bars that are displayed in that chart. Now it's important to note at the moment this chart is in aggregation mode, and that's why we have not only the column of mean, but we perform an aggregation over that y-axis column. In this case, we are getting the mean values for each state. We can also set that to different aggregations, for example, count, and you can see in this case the state of Texas has the most rows in the data that have a mean. Texas has 2,300 rows, followed by Florida, and that goes all the way down to South Carolina here. And that's why when we sum these up, you're expecting to see Texas at the top, because it has the most rows and therefore the most mean values in the data. And when it sums those up, it gives us back that. So when we are applying an aggregation, we want to apply the mean here in order to give a balanced representation of the actual mean values for each state. So that was a quick aside. I hope that makes sense. Let's now move on. Another thing we can do here is transpose this chart. So that's very simple to do. We have this tool here. When we click that, we are transposing the bar chart, and now we have a horizontal bar chart rather than a vertical bar chart. And I think this is a bit clearer for this data. We have the states on the left hand side on the y-axis, and on the x-axis we have the mean values for each state. So we can see how easy it is to create these bar charts and to apply sorting and transpose the chart, and also change the layouts of the charts. And also we can see how to apply filters to the charts. What I want to do now is just show how to change the chart that's displayed here. So currently we have a bar chart. What I'm going to do is remove these filters from the chart, and I'm also going to undo the transpose of this chart as well. And what we're going to do now is we're going to change the type of chart that's displayed here, and we can do that by clicking this icon here for the mark type. And you can see the different options we have, for example, the line chart, the area chart, scatter charts, and other charts as well. So I'm going to click the area chart, and we're going to see how this affects the resulting visualization. And actually you can see that has removed everything from the visualization. Let's also remove the color from this filter field here. And now you can see the chart, and you can see the different states that are contributing the highest mean here, from the District of Columbia down to the Mississippi and Puerto Rico states. Now if we wanted to take the summation here rather than the mean, what we can do is change the aggregation to the sum, and you can now see very clearly that California has the highest sum of means in this data. And you can probably infer from that that California is the state that contributes the most to the US GDP. Let's now move on and create another type of chart. This time I want to create a scatter plot in the PyGWalker UI. And I want to show on this scatter plot the mean values that we're getting from the data for two states, one being California and the other being Mississippi. So because we're going to show each observation from the data frame, I'm going to turn off this aggregation mode. And what that does is it removes the aggregation function from the y-axis, and it's then going to just use the raw data. And you can see the plot that's created here for the area chart, and you get to see every single point in the data, and it creates this rather crazy looking area chart. So on the x-axis we have the state name, and on the y-axis we have the mean. Let's now add a filter to this chart, and we're going to only filter it down to Mississippi and to California. And you can see that filter on the left hand side. We have one of California and Mississippi, so it's only going to show the values for those states, and this chart doesn't really make a lot of sense at the moment, so we're going to change the type of chart now to a scatter plot. So we can select the scatter option here, and then on the right hand side we now get this scatter plot. You can see from this scatter plot that California has a greater variety of values here, a greater standard deviation, and you can also see that it has much higher values in general than Mississippi, but we can see this better actually with a different type of chart. I'm going to change the chart type here to a box plot, which you can select near the bottom, and that will give us back this kind of chart that you see here. You can see the interquartile range here, and that is displayed within the box that you see, and that range is much higher for California than it is for Mississippi. And when you hover over the box, you can see some of the statistics here. For example, the median value for Mississippi is 47,423, whereas for California it is 72,331. So that median value of the mean incomes for California is much higher than it is for Mississippi. And we can also see at the top here some outliers in the California data, some very high numbers for the mean income. And this implies that there are certain areas in California where the mean income is much higher than the average, and a box plot allows us to see this kind of data in a better way. So what we can also do when we've generated the charts is we can export them to a PNG or an SVG file. In order to do that, you can click this icon here to export, and you get to select the type of file that you want, and that will export the resulting chart as one of those file types. Let's move on. We are going to show one more example, and then I'm going to very quickly show how to integrate this with Streamlit at the end of the video. We're now going to show a different type of filter here. Rather than the state name, which is a one-of filter, we're going to show a range filter now. So let's go back to aggregation mode, and on the y-axis again we're going to select the mean aggregation function over that column, and we're also going to go back to a bar chart here. So this is the aggregated values of the mean for California and for Mississippi. You can see that California's mean is much higher over this data set than Mississippi's. I'm actually going to remove this state filter that we have here, and I'm going to add a different type of filter instead. So let's grab the latitude column here, and we're going to scroll up and add that as a filter, and we can see a different type of filter here. It's the range filter. Now I'm just going to randomly select a lower boundary for the latitude, and we're going to go up to the maximum value for that latitude as well. So let's confirm that, and we're going to see the resulting chart. Now I'm not sure if this has cut back on any of the states, so let's go back to the filter here and increase this latitude filter and confirm that. Now when we do that, we get back a single bar, and that's for Alaska. So obviously I've went too far here. The lower boundary of the latitude is actually too high in this example, so the only US state that is north of that latitude is Alaska. So let's adjust this slightly and go down to, let's say, 41. And you can see we are now getting back more states. I'm just going to adjust this slightly again, and let's go up to 46 now and confirm. And the states that we're getting back this time include Alaska, Washington, North Dakota, Oregon, and so on. So these are the most northerly states in the USA. And the purpose of this example is simply to show that we can use these range filters here. It's a different type of filter that we can apply to the data in order to filter down what the resulting chart is showing. So let's now move on, and what we're going to do to finish this video is show how to integrate PyGWalker with Streamlit. So what we're going to do is open up VS Code, and I have opened the directory that contains the data file, which is the CSV file, as well as the Jupyter Notebook that we've been working with in this video. What I'm going to do now is create a new file, and let's call this file main.py, and this is going to be the file that contains a Streamlit application. Now once we've got that open, what I'm going to do is go back to the Jupyter Notebook, and I'm going to copy the code to read in this data frame into this particular file. So let's copy that in at the top, and we can remove the call to the dataframe.head. We don't need that. And what I'm going to do is activate a terminal here, and within that terminal, let's activate a virtual environment, and we're going to install PyGWalker using pip. So let's run the pip install command, and we're going to pass the name of the library PyGWalker to that command. And once that's installed, what we're going to do is go to the documentation here, and I'll link this page below the video. This is a page on integration between PyGWalker and Streamlit. And as it says on the What is PyGWalker section, this is a library that allows you to generate scatter plots, line plots, bar charts, and histograms with simple drag and drop actions and no need for coding skills. We've already seen a little bit of that, but if we scroll down a bit further here, we have a section on Streamlit and also how to integrate the two. And of course, we need to have Pandas, PyGWalker, and Streamlit installed for this example. Now, it's this section here on embedding PyGWalker in a Streamlit application. What I'm going to do is copy these imports at the top, and I'm going to bring them into VS Code. So let's go back to VS Code, and I'm going to replace the Pandas import with all 4 of these. And let's go back to the documentation, and we're basically going to copy these 2 lines of code here, and again we'll bring them into VS Code. So what we're doing here is we're using Streamlit, and we're setting some page configuration. We're setting the layout to wide, which is what we want to do because we want to show this PyGWalker UI on the page. So the wider the page, the more room we have to work with for that UI. We're also setting the page title, which will be shown on the browser. We'll show that in a second. And finally, we're explicitly adding a title to the Streamlit application, and the title is Use PyGWalker in Streamlit. Let's go back to the documentation, and we are going to copy this line of code here, and I'm going to paste that in and explain what's going on here. So if I paste that at the bottom here, we're creating a variable called PyGHTML, and again we're calling that walk function that we called in the Jupyter Notebook, and we're passing the data frame to that function. But we can also pass a keyword argument to the function, and that's return HTML, and we're setting that to true. Now the default argument for this parameter is false. When we set it to true, what's going to happen is when we call the walk function, it's going to return the HTML for the PyGWalker UI, and then we can use that HTML within the Streamlit application and show this particular widget on the page. So we get back the PyGWalker HTML. Let's go back to the documentation one more time, and again we're going to copy this line of code, and we'll paste that just below this HTML. So what we're doing in this line of code is we're embedding the HTML into a Streamlit application. And we do that by calling the components.html function, and we pass the HTML into that along with a height and the parameter of scrolling set to true. Now what is this components that we're using here to call an HTML function? If we scroll to the top here, you can see this import where we're importing streamlit.components.v1 as components. And this module has this HTML function that we can use in order to embed external HTML into our Streamlit page. So if we go to the documentation very quickly, there is a page on these components, and you can see this create a static component section here. If your goal in creating a Streamlit component is solely to display HTML code or render a chart from Python, then Streamlit provides 2 methods that greatly simplify this process. That's the components.html function and the components.iframe function. And we are using this components.html function that's defined. So that explains what this code is doing, and all we need to do now is actually run the Streamlit application and see what kind of output we're getting on the page. Now in order to run a Streamlit app, we can use the command line tool, and we have a command called run here, and we can specify the name of the file, and that will then run that file and load it into the browser. And when the page loads here, you can see the title that's appearing, and after the loading is complete, we should see the PyGWalker UI just below, and you can see that has appeared in our Streamlit application. It's embedded here using that components.html function. And again, we can drag and drop these columns from the data frame into the X and the Y axis sections here. And that is going to generate this chart here. And again, we can change the aggregation function, for example, by selecting mean here. And as before, we can also change the order in which these are displayed. So let's sort in descending order. And that gives us back the state with the highest mean income according to this data set. So very simple to integrate this PyGWalker widget into a Streamlit application, and this might well work with any backend framework, for example Django or Flask. And that's because if we go back to VS Code here, when we call the walk function, we can get back simply HTML that we can then embed into our application. So that's all for this video. We've learned how to use PyGWalker in this video, and we've seen how to generate a variety of different charts and how to sort data and transpose data, and also add filters to the charts to customize what's been shown at a given time. And finally, we've also seen how to bring PyGWalker into a Streamlit web application in order to show that widget in the context of a Streamlit application. It's very easy to do that. I'll leave all the links below the video for these particular pages that we've looked at. Thanks again for watching this video. If you've enjoyed it, please like and subscribe to the channel, and we'll see you in the next video.